Hey there, Math 124 fans. Going to continue this series. Part 3, I'd like to talk about continuity, differentiability, and I'll throw in here graphical problems. So in a second, we'll do some graphical problems. You know, continuity and differentiability, casually, and there's subtleties I shouldn't be too casual about, but casually, continuity means there are no breaks. Differentiability means the slope always matches up everywhere. So casually, when I look at this problem, the points of interest are 0 and 1 right away. And so the question is, I want the functions to match up. So how do we make the values match up? Now, formally, we are trying to ask a question about limits. What is the limit as x approaches 0 from the left? I want that to be the same as f of 0. And I want it to be the same as the limit as x approaches 0 from the right. Technically, that's what continuity is, but in this case, I can plug in 0 everywhere, so there's not that much concern. As you approach from the left, you're going to get -1. As you approach from the right, you're going to get b. How did I get that? I just plugged in a 0 to both those. Now, technically, when you plug in 0, you get b because of the definition, because it's less than or equal to. But that tells you everything you need to know. B has to be -1. So continuity tells me that. Okay. What else can I say? Well, what about at 1? What's the limit as x approaches 1 from the left? And I need that to be f of 1. And I need it to be the same as the limit as x approaches 1 from the right. I guess this question didn't mention differentiability, but you would first check this continuity. So from the left, if you plug in 1, you get a plus b. If you plug in 1, you get a plus b, because that's less than or equal. And then the other one, when you plug in 1, you get the square root of 9, which is 3. Since you know b is -1, that means a has to be 4. Okay, so that's a really fast question, as long as you know the idea if you're trying to get things to match up. Okay, let's move to the graphical questions. So I found just a few old exams where they asked this. It's usually what's challenging for students on these sorts of questions is it's lots of different questions in one. So you have to pause yourself and be like, okay, there might be some pieces of this page that are hard for me if my understanding isn't clear, but there should be parts that are fast. So they give you this graph, and you want to read the description. It says we have a little parabola, we have a line, we have a circle, we have another line. They give you very clearly labeled points. We have a solid circle here, an open circle. We have a little break here. So casually we can say a few things before I read the questions. And sometimes it's a good strategy. Try to anticipate a little bit what the questions are. Like, hey, there's a sharp point here. So here is an example of a place where it's not differentiable. It is continuous. There is no break. You can draw it with your pen, but the slope is different from each side. Here's a place where it's not continuous. Here's a place where it's not continuous. We call this a removable discontinuity. I mean, if we just move that point, we would be fine. This is a bigger issue because it jumped. Here is a place where slope doesn't make sense. So I have these 4 places, 0, 2, 3, and 7, where interesting things are happening. Likely in a question like this, they might also ask about places where the slope is 0. And in that case, I only see 2 places where the slope is 0. Or where the slope is undefined. And the slope is undefined at all those places as well. Okay, so let's just go through the pieces. What's the limit as x approaches 2? Well, it's 2. That's part of the reason we have this limit definition, is to have the ability to say that. Okay. What is the value at f of 2? Well, it's 1. What is f prime of 2? I think in that situation we say it's undefined. These are subtleties. I'm afraid to say too much. Let's pull up it's this midterm. I have a little self-doubt. Okay, it does not exist. I should know that right away. I just don't want to make a video and give you the wrong information. Slope makes sense on each side of it, but because of the definition of the derivative, you have to be continuous first, or else you'd have a value it could be equal to. Okay, I remember now. So this does not exist. What about this? This is a definition thing. If I plug in 7 to this, if you look, some of my thoughts are, well, what is f of 7? It's 4. So this is the definition of the derivative at 7, but from the right. So it's saying, what is the slope from the right, and what is the slope from the left? The slope from the left is infinite or negative infinity because of this thing here. So that would depend on the instructor. Let me look at that again. Negative infinity, okay. This is the part where it's bad that I haven't taught this recently. You can see some of these little pieces. Okay, so then 8, 5, that's the slope. 5, so 1 over 1. So this is just 1. What is this? This is talking about if you plug in, so this looks like, yeah, it does look like, looks like f of 1 plus h. So you have to suspect that maybe it's talking about the derivative when you're doing a problem like this. That's the definition of the derivative at 1. I first checked that f of 1 is 1. So this is asking about the slope at x equals 1. And we can compute that slope. It's also 1. It's perfectly well defined. List the x values where the slope is 0. Well, I already mentioned those. Negative 2 and 5. List the x values where it's not continuous at 2 and 3. List x values where it's not differentiable. That would be 0 between negative 4 and 4. Okay, at 0, 2, 3, and 7. Oops, I missed a couple questions. True or false? F of x is left continuous at 3. Oh yeah, they must use that term now. Last time I taught it, we didn't talk about left and right continuity. Is true or false? Is left continuous for all values from negative 2 to 8? No, it's not left continuous at 2, so the answer is false. Let's see how I did. And what's hard about, like, again, there we go. Yay! I think I got them all. So there's always subtleties, I know, but a lot of those were straightforward. A few of them you're going to have to think carefully about the definition. So if you're worried, you would do a lot of practice with that, and you would add those, as many of those subtle definitions. And someone who's actively in the course, you've thought about that more. Here's another one. The graph of a function is shown. This is from one of my old exams. It says, can you give a rough sketch? Now, the important things here, which you're sort of starting to figure out, is we're talking about slope. I like to tell students, the key features, if you write slope here and you write height here, you can make a little number line to indicate the key features of a graph. Where do things change? And so first we're going to label the critical points, the points where the slope is undefined, which happens at negative 2 because there's a sharp point. It also happens at 2 because the slope is 0 here. And it also happens at 4 because the slope is 0 here. Then we can signal what's happening in between. The slope is negative, and then it's positive. See, it's uphill, and then it's negative, and then it's positive. So the quick snapshot of this graph is that it does this. That gives us a whole bunch of information in terms of how we graph our function. We know the slope is 0 at 2, so right here there needs to be a dot. We know the slope is 0 at 4, so right here there needs to be a dot. We know the slope is positive after 4, so the graph needs to be somehow up here. Now, how steep to graph it, that's a different question. But that's not usually something we're testing when we're doing this. Then it needs to be negative and somehow connect these two. The biggest negative slope would be like right here, but anyways. And then the slope is positive. But an interesting thing here is it appears the slope, like from here to here, is a constant. And it appears the slope from like here to here is also a constant. Can I estimate what those are? Let's see, I go rise over run. So I go down 3 and over 3. So the slope is negative 1. It looks like this is the same slope, so I'm going to go over 3, up 3, so the slope is 1. So the only thing that's sort of goofy about this one is I need to draw a slope of -1 right until here, and then I need to draw a slope of 1 right until here, until I get to 1. And then it's going to get closer and closer to a slope of 0. So it's going to look something like that. But if we were grading, we would really need to see that it's positive when it needs to be positive, it's negative when it needs to be negative. Anyways, it's constant where it needs to be constant. You got to be thinking in terms of slope. This is what we're learning initially. Find the values of c that will make this function continuous everywhere. So we need the limit from the left and right to be the same as the value. From the right, it's just 3 squared, so it's going to be 9c plus 10. From the left, it's one of these limits where we're going to need to factor x plus 3, x minus 3 over x minus 3 cancels. The limit as x approaches 3 from the left is 6. So from that, we can solve for c and get c as -4/9. For the value you found, is it differentiable? So that question's asking about the slope. The slope from the left and right, are they the same? So we would have to check. On the right, you're getting the derivative would be 2cx. If we plug in that and we plug in 3, we get 2 times -4/9 times 3. So we get -8/3. What about from the other side? X squared minus 9 over x minus 3, which we now know simplifies to x plus 3. What is the slope? The slope is 1. They don't match up. From the left, the slope is 1. From the right, the slope is -8/3. They don't match up. No, it's not differentiable. Okay, I think that's enough.